Okay, hello everyone. Welcome to the Studio 5 review. I was a little bit behind in getting this one posted. Sorry about that, but there's a lot of good stuff to talk about this week in Studio because we are introducing a very important concept. This week we're talking about methods. So methods are something that we're going to be using for the entire rest of the semester. Extremely useful concept that allows us to organize our code by different behaviors, different actions, and then reuse those actions over and over again as we need to throughout our program. So let's start by taking a look at the first method that we're asked to look at is this one called distance between. I'm going to start by reviewing the parts of a method. The first two words that we see here when the method is defined are public and static. We actually haven't talked a lot about what these two words are just yet. They are necessary to be included, and we're getting closer and closer to talking about these in more detail. But for now, we're just going to include them as sort of magic words that our methods need. The next part of our method definition is the return type. In this particular case, the return type is telling us that this method is going to return a double, which means that it is always going to produce a double and give back that output as the output of the method. Following the return type, we have the name of the method, and then following the name, we always have a set of parentheses followed by the input parameters, which you can see there are actually 4, which is kind of a lot for this particular method. X1, Y1, X2, Y2. So we're supposed to compute the distance between these 2 points. That's the goal of this method. And then after the method has been defined, we call this the method signature. Then we see the curly braces here. That surrounds what we call the method body, which includes the statements and the codes that we want the method to execute whenever we use the method. So really, this is just a template, and I'll show you a little bit later on what happens when we actually need to use this method. But for now, let's see if we can figure out how to make this method work. We need to compute the distance formula, which I'll be honest with you, I have to Google it. Don't feel bad if you have to Google things and figure out how to turn that into code. That's pretty common, so it's going to be the difference of the x values squared plus the difference of the y values squared, all square root. Okay, we can do that. We're going to have to use math.square root and maybe even math.pal perhaps, but let's see. It starts with math.square root. I might break this into chunks. I might do the x part first. So that's going to be x2 minus x1. And then we're going to multiply that by itself to square it, right? Okay. And then we'll make the y part, just to make this a little bit easier to see, hopefully. There we go. And then we need to add those two together and take the square root. All right. So then x part, plus the y part, and then we need to take math.square root of that entire thing. That's going to give us the distance. Okay, there we go. Get rid of that, we don't need it anymore. And then this statement, remember, it does two things. It says that this is the answer, this is the output value, and then it also says we're done. The method is over. We're going to stop, and we're going to go back to wherever this method has been used or called. So at this point in time, we can actually verify that this method is working by using something called unit tests. And so we've given you a bunch of unit tests for this studio. We asked you to start by looking at the distance between test here. And there's some explanation as to what's going on, but we're actually using assert equals to compare an expected value to what's actually computed. So what we're saying is that the distance between these 2 points, which are exactly the same point, right? 1, 0, 1, 0, should be 0. So hopefully when we call our method. That's what this is. This is the line of code that is calling our method. Hopefully, when the method runs through and computes the stuff, if we did it properly, it will generate the proper answer of 0 and give us an indication that it is working. Now, there's always going to be some error factor involved, and so this third value over here is a wiggle room. It's a little bit of tolerance that we allow our answers to be off by just a little bit in order to acknowledge the fact that not all computations are exact, and sometimes there's going to be little rounding errors and things like that that cause the values to be not quite exact. So there's more tests down here, but they all follow the same general idea. This test is saying that we expect a value of 1 for the distance that is computed between 1, 0, and 2, 0. And that makes sense, right? The distance between these 2 points should be about 1. So if we plug these values into our method and call it, again, that's what this highlighted section is doing. It is calling our method. It is actually using the values shown here in conjunction with this code that we wrote, and then plugging them into this formula, and then returning the value. Hopefully the value that gets returned is going to be the expected value of 1. That's what these tests are trying to do. So let's go ahead and run the test. If we run distance between tests, we can see that the first 4 pass all right, but this last one doesn't. And if we jump down to it, we can see there's actually an error here. It's testing to see that the distance between 0, 0 and 30, 40 is 50. And if we take a look at how things are happening here, when the values are plugged in, we can see that we're not actually reflecting what we're saying we're reflecting, right? 0, 0, 30, 40, these parameters got switched. There's an error in the unit tests. This is oops, definitely don't want to do that. This is an important thing to understand, the idea that these tests, while useful, and while a lot of people get used to telling these tests telling us whether we're on the right track or not, can have mistakes. They're code written by human beings, so these tests can have mistakes in them. But once we fix the mistake, we're actually testing the thing that we hope we're testing for, the distance between these 2 points. Then we can rerun these tests and hopefully see that, yes, all of the distance between tests are now passing. So before I move on, I want to show you again just exactly what's happening when these tests are running, and exactly the path that's being taken when your method is called, and those values are going in with the return value coming out. So what I'm going to do is I'm actually going to set a breakpoint in the unit test. This is a test that is testing my distance between method for these 2 points, right? So I'm going to go ahead and set a breakpoint here on line 23, and then run the unit tests in debug mode. That paused me here on the unit test line 23. And if I use the step into method here on line 24, we'll now see that I'm inside my distance between method with the values that have been chosen for this test, 1, 0, 1, 0. And we can actually walk through and see how this code is computing the distance. So the x part is 0, the y part is 0. That makes sense, it's the same point. This part's also going to be 0. And then when we return it, that value gets passed back to where the method was called and compared against the expected value. Since they are the same, the test is happy and passes. Alright, now that that method is finished, let's move on to the next one. The next one we're going to take a look at is the draw bullseye method. So the draw bullseye method has already kind of been started for us. It sets the color to black and draws a circle on the screen. And if you run the draw bullseye debug app, you'll see what this looks like, right? But that's not quite what we're going for. We're going for something that looks kind of like this, with smaller and smaller circles until we hit the center of the screen. And so, you know, we don't actually have that done yet. But once we do, we can run the debug app again and see what it looks like. So we're going to try and draw the remaining rings here. We need to draw a blue ring with 3/4 of the radius, the radius of the black ring. So they're giving us some suggested values. We can go ahead and do that. We'll say standard draw dot set pen color, and then pass in those three values: 0, 109, and 219. And then we'll draw our circle. The center is the same, right? All of the bullseye circles are centered on the same XY coordinate. It's just the radius that's smaller. So we just need to multiply this radius by 3/4. And be careful how you do this, right? Notice how I used a double. That should be division multiplied by the radius. There we go. So now let's run this app again and see. Okay, got the black ring. Now I have the blue ring. Need to keep going. Need to do the red ring and the yellow ring. So let's go ahead and do that next. I'm actually just going to grab these two lines and pop them down here so we can do the, this will be the red ring with 1, 4, 6, 0, 0. It wants us to use half of the radius of the black circle, so I'll switch this to be 1/2. Now when we run the debug app again, we'll see that I've got the black, the blue, and the red, so that's good. Finally, we need to add the yellow part for the center. We'll use 255, 255, 109 for the suggested color, and then it's 1/4 of the radius of the black. So once we go ahead and do this, we should see the full bullseye. But what's nice is that after we see the bullseye, this application goes a step farther and shows how using the method allows us to draw bullseyes in different parts of the screen with different sizes. We actually have the ability to reuse this method in a very effective way. So this method is generalized enough that we can use it to draw multiple bullseyes and display them all on the screen. And actually, if you want to see the code for that, you actually have it all. It's placed in, let's see, let me figure out where. It's going to be in these draw bullseye cases. Oh, here we go. So here you can see where it's drawing the new bullseyes, right? And the method is actually getting called here. So there is a little work that we provided. Actually, you won't understand how this code works, written by Professor Cosgrove, until we get to Module 7. But what I wanted to show you is that we're actually using your code, right? We're using the bullseye method many times throughout that debug app in order to draw that bullseye repeatedly, because the method is written in such a way as to allow us to do that, right? It's not just drawing that one specific bullseye on the screen. We've written this method in a much more general way that allows us to draw bullseyes in many different locations in any part of the screen that we want to. That's a good method, a method that can be reused in many different situations. All right, let's take a look at the next method. The next one we're looking at is called substitute all. And what we're looking at here, to understand what this one is, because this one is a little bit trickier to understand than some of the prior ones, this is called JavaDoc. This is documentation that can be used to describe the inputs and the outputs of the method, as well as what the method is trying to do. So it's saying that it's going to return a new string, which is the original source string, with all occurrences of the target character substituted by the replacement. So we're given a string, some text, right? Could be, the word hello. If I say to replace the letter L with the word hi, then it would say, H-E, hi, hi, O. So it actually replaced those letters with the replacement string, whatever is specified. I believe the examples shown here. Oh, they actually don't give some examples, but they do give you some methods that allow you to access the different characters within the string. So to-char array is a good method to use. The char at method, I believe, might be the one that I'm going to use which is, let me do a search for it. Yeah, I like this char@, method, so I think that might be the one that I'm going to use for today. But the idea behind this method is we're going to write a loop to go through this string one character at a time and then compare it to this one. And if we find that it matches, then instead of, passing this character along, we'll use our replacement string instead. And in order to achieve this, we're going to use repetitive concatenation. I believe we can do this with a for loop here. I is going to go from 0 to the length of the string. A string is just an array of characters. So the letter at index 0 is the first letter, the letter at index 1 is the second letter, so on and so forth. So this loop will iterate through all of the letters of a string, just like a similar loop would allow us to iterate through all of the contents of an array, for example. And now we can use the char@, method to check, to see if the character at a given position is equal to the one that we're looking for. So we're looking to see if the source character at I is equal to our target character. If so, then our result is going to take on the value of the replacement. If it's not equal to the target character, then our result will just take on whatever character that was. So if it's not the letter we're looking for, we're just going to pass this on to our result. So for our example of hello, right, the H, if we're looking for letter L, I'll just pass the H right along, right? I'll pass the E right along to the result because those aren't our target. But if I'm looking for L, then I'll match this, and instead of passing the character through, I'll pass the replacement string through. Once we've made it through that entire loop and concatenated all of those values together, we can finally return our result. Let's take a look at the test cases for this. So I think it's important to see how this method is used and what it's used for. So here's our substitute all tests. R is a R is a R is a R. So it's going to go through, look for all of the letter R's and replace them with the word rose. And so after it does that, it's expecting to see rose is a rose is a rose is a rose, right? B is T, T, B. So this is actually calling the method, passing in the source string, the character that we're searching for, that's called target, and then what we want to replace it with. Okay. Let's see what our next method is for the studio. Now we're going to talk about arrays more directly. So strings are kind of array-like, but our next method is going to use arrays directly. Here we have a method that takes in an array as a parameter. So here we're taking in an array as a parameter. We want to compute and return the sum of all the values in that array. So this is actually a very well-known pattern. If you are using the typical loop, the typical for loop that we use to go through arrays, that's a good place to start. And then we'll say sum is plus equal to values at I. We use this kind of pattern so often that we have a name for it. It's called the accumulator pattern. We're accumulating everything in this sum variable and then spitting out the final computed value once the for loop is over. This is a pretty simple, straightforward method, I hope. But what I also hope you see is that it's useful because we can now plug in any array and get the sum of that array. We don't have to redo this code over and over and over again for every array that we have. We can write this code once and then plug in all of the different arrays that we have and reuse this code. And again, kind of with the theme of today, for the array sum, if we take a look at some of the tests that are provided, you can see that it's creating some very simple arrays, calling the method to see what happens, and then comparing it against the expected value. So if we sum this array, I expect the sum to be 30. Well, this calls the method, computes the actual sum, and then compares it against that expected value of 30. Let's run these tests and see if our whoops, I ran the wrong test. I ran the array mean test, which is what we're getting to next. Let's run the array sum tests, since that's the one that we were working on, to see that they do all in fact pass. All right, I believe the next method is actually going to, oh, okay, never mind. We have another stop before we get to the one that I was thinking of. Our next stop is a method called filled array. So we want to create a method that is now going to use an array as a return type. So again, notice that arrays are valid types. In fact, anything that we've seen used as a type can go as a type of a parameter, or as a return type, or as the type of a variable. So types can go in many, many, many different places. All right, so this method wants to return an array of the given size filled with the provided value. So it needs to create an array that's this size and then fill that array with this value. All right, let's do that. We need to create an array of that size. So I'll say new int length. That's how we create an array. And then we'll write a loop to go through. And we'll set all of the values equal to values. We already have the return statement provided down here, so I believe this method should work. Let's run our filled array test suite and see. Whoops. All right, well, let's take a look at this test and see what happens. Here it's telling us that it's creating an array with length 2, wants it to be filled with 4 values, so it's calling our method right here, saying go off and create that array, getting that return value and storing it in this variable, and then it's saying, all right, let's make sure that the length is equal to, and here's where there's another mistake in the code. So it's actually comparing the length of the array against the wrong variable. It's comparing it against value. It should be comparing it against length. So let's fix that mistake in the code. Again, this is code written by humans. It can also be incorrect. So let's fix that mistake and run it again and see that, yes, we also do have passing tests now for our filled array. And for the last couple methods here, we actually are asking you to do everything from scratch. So we're asking you to do a method called array mean, and I believe that's actually the last one that we're going to be looking at today. So if we scroll down here to the bottom, we're asking you to do this one from scratch. So again, as a reminder, we're going to do public and static. Those are our magic words to get things started. We now need to decide on the return type. So if I'm taking the average of an array of values, the instructions might actually tell us, let's see, it's telling us that it should return, it actually doesn't. It's asking us to consider what the appropriate return type should be, and then giving us some examples. So leaning heavily towards double, I believe, right, would be a good return type to use here. The name of the method is called array mean. And then the input parameter, what would it take in? Well, it's going to take in an integer array of values of which we want to take the average of. Another important thing to keep in mind here is that we actually already have some code to help us with this. We have a method up here that can be used to sum values, and that's part of the process, right? So instead of doing this, which would be, copying code and then pasting it down here, we can actually just call that method directly. We can actually just say array sum of values, and that will get us the sum of the values. And we can even store that in a variable. And then to get the average, we just need to divide by the size. And there we go. I believe that should do it, but let's run the tests and make sure. So we should have some array mean tests, and let's go ahead and run it and see what happens. Oh, and some of the tests pass, but some of them don't. So if I look at some of the ones that don't pass, I see 1, 2, 3, 4, it expected 2.5, but what did it get? It got 2. And so it's off. Actually, to me, I kind of saw this mistake coming. We're doing integer division here when actually we need to be careful. It could be a double that we need. So let's try changing the type of this to double and see if that helps us out. Much better. Yep. And now again, I want to make it absolutely clear how valuable it is to have this method to lean on. If I go into one of these tests, I want to show you what happens when it actually computes the mean of one of these by setting a breakpoint on one of the tests. Oops. What am I looking for? Well, I'm looking for array mean preliminary test. Here we go. Yeah. Actually can't find the one that I'm looking for. Alright, sorry about that. I'll have to go back and review. I don't want to waste any more time on the video searching around for something that I can't find, but that's okay. The point remains that if I go back to the methods here, right, when we make it into the array mean method, it's actually going to kick control up to the array sum method. Work through all of this and use the array sum method to help compute the mean. So we're actually reusing code instead of having to rewrite it over and over and over again. That's a good thing. That's what methods do for us. That's what we want. And so for the homework assignment this week, you're going to be continuing on with what we started you on last week with the zombies assignment, except this time you're going to be completing a bunch of different methods that define different parts, different behaviors that we want our code to have, such as the movement of the zombies, what happens when the zombies touch a human and turn them into zombies, or not, for example. And so all of that will be segmented, and you'll be able to actually use those methods over and over in a repetitive fashion to simulate, little zombie human simulation. So it should be a great assignment. All right, that's going to do it for this studio review. Thanks. I'll see you in class.